Welcome to today's lecture on the decimal system. I'm Drew Collop. In today's lecture, we're going to review what the decimal system is and how we round off appropriately. You might think this is pretty basic. We want to make sure everyone understands. The way rounding is taught in different parts of the world is different. So we have to make sure we're all doing the same thing. It doesn't matter how we round as long as we all agree we're going to do it one way. So I'm going to explain how we're going to round it here, and it may be different than you were taught if you were taught elsewhere in the world. So let's start with the decimal system. The decimal system, deci means 10. This is a system that is base 10. It's a positional number system. It takes 10 units to equal one larger unit. So as an example, let's start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've now taken up 10 spots, 0 to 9. Now we'll go to the next place value. It goes to 10. Then we continue. 11, 12, 13, all the way up to 14, 15, 16, 17, 18, 19, 20. And you can see after we do another 10, it switches to the next level. This becomes a 2. Now you might wonder why I'm spending so much time on reviewing these numbers. Because there are different numbering systems that exist. This is the decimal system. Let's review two others. Two others include the binary system, that's base 2, and the hexadecimal system, which works with a base 16. So let's review those quickly. So with binary, 0 and 0 mean the same thing. And then we have 1. The next number is 10. Let's add some extra zeros in there. The next one is 11, and then 100, and then 101, and then 110, and then 111. You can see here it's only using two numbers, zeros and ones. This is how computers count. After we get to finish off all those, 8 is actually represented as 1000. We then have hexadecimal. It's even crazier. Here we start off at 00, 01, 02, 3. So initially it starts off the same. When we get to 10, however, A, B, C, D, E, F. Now we've done 16 individual numbers. And now it switches up. This goes 10, 11. So you can see it may look very basic. You're counting numbers with decimals. However, there are different systems for counting. Decimal is what we're using, but if you work in computers, you could be working in either binary or hexadecimal. So I just want to make you aware that those systems do exist. Let's continue on with the decimal system. This should be review for all of you. So if we're given this number here, 351.3, the position of each of these numbers represents something. So we have our decimal point here, the 1, the 5, the 3, and the 3. What this represents is 3 hundreds plus 5 tens plus 1 1 plus 3 tenths. So we can build them up together. If we take all those individually together, we can get the number 351.3. So depending on the position of the number, depends on what column it is in. We have ones, tens, hundreds, thousands, 10,000s. We have the decimal system. This breaks up wholes from parts. Now please note, there is no once column. Just try and say the word once. You really can't say it. So we start off with tenths. 0.1 is 1/10. And then hundreds, thousandths, 10,000ths, and so on and so forth. So please be aware of those different numbers. Let's look at an example of a few different numbers. Every Canadian uses one tree of approximately 45 centimeters in diameter, 30.54 meters high, and there are 25.4 trees planted per person in Canada per year. You can see in all these numbers, let's write them down here. I have 45. You don't see the decimals, you assume it's right there. We have 30.54, and we have 25.4. In each of these, they all have a 4. The 4 has a different spot within the number compared to the decimal. So each of them has a different place value. So this one here represents 4 tens. This is worth 40. This 4 here, this one is in the tenths column. This is 4 tenths. Notice the TH. This is worth 0.4. And finally, this 4 here, it is in the hundredths column. So this is 4 hundredths with a TH, and that's equal to 0.04. So depending on where the number is in relation to the decimal, depends on the place value. Very important. Again, that should be review for you. In order to make sure you understand place values, please pause your video and try this exercise. I want you to write down the place value of the digit that is underlined in each of the numbers. As an example, this 2 here, that's ones, tens, hundreds. So this is in the hundreds column. Try the rest on your own. Let's take them up. Tenths, hundreds, thousands, 10,000s, 100,000ths, 100,000ths with a TH. Here we have tenths. Remember, there is no once column. Right here, we have the ones. Here, 4, we have tenths, hundreds, thousandths. Thousandths with a TH. Here we have tenths, hundredths with a TH. What do we have here? Ones, tens, hundreds, thousands, 10,000s, 100,000s. 100,000s with no TH. Over here, tenths, hundreds, thousands, 10,000s. With a TH. Here, we have tens. Finally here, ones, tens, hundreds, thousands. No TH. Hopefully that was review for you. Now, previous to this lecture, we did a lot of work on fractions. Let's combine it all together, because quite often we switch between fractions and decimals. So let's use an example that we have. A 25-cent piece here in Canada is called a quarter. Why? Because it's a quarter of a dollar. As a fraction, it can be written as such. Why? Because 100 pennies makes a dollar, and a quarter is 25 pennies. We can simplify that down to 1/4. That's why it's called a quarter. However, when we're doing our financial transactions, we don't write it in fractions. We write it as a decimal. Any fraction can be written as a decimal. Any fraction. But not all decimals can be written as a fraction. Remember that. Any fraction can be a decimal, but not all decimals can be fractions. Think about that for a second. Why is that? Let's explain why. Here I can write any fraction can be written as a decimal. So anything. You pick any fraction. We have 1/4, 0.25. But not all decimals can be written as fractions. Let me explain why. So here's a decimal, 0.75. I can write that, 0.75. I can write that as a fraction, 75 over 100. I can then simplify that down by taking a 25 out of the top and bottom, and I have 3 over 4. So this is a decimal that can be expressed as a fraction. What decimals can't be expressed as a fraction? Do you know that number? That's the value of pi. Pi cannot be expressed as a fraction. Please don't write it as 22 over 7. It's an approximation, but it's incorrect. Why can't we write it as a fraction? Well, because it is non-terminating, meaning it doesn't come to an end. The numbers keep going and going and going and going. But the other thing is, it's non-repeating. That's important. So something like 0.66666666666 off to infinity, that is non-terminating. But we can write that as a fraction of 2 over 3. Why? Because it is repeating. 3.1415926, so on and so forth. It is non-terminating. It is non-repeating. So it is called an irrational number. It cannot be expressed as a fraction. Do you remember that from day one? Irrational numbers. If you watched the video on the golden ratio, you would have learned that the golden ratio number is the most irrational number. So if you haven't checked out that video, I would advise you to check it out. Let's look at some examples. I want you to try these on your own. Convert them from a fraction into a decimal if they can be done, and tell me if they're terminating, non-terminating, if they're repeating, non-repeating, and if necessary, please use the bar notation if you know what that means. Then we'll take it up. Let's take it up. 3/6, if we type that in our calculator, that would be 0.6. So this one is terminating. It ends. 0.6, done. No continuing on. 3/9, we can write that as 0.33333, and it goes on forever. I can write that as 0.3, and I put a bar over the 3. This indicates that whatever's underneath the bar, I just keep repeating that off to infinity. So this is non-terminating. It doesn't end, but it is repeating. So that's how we can write it as a fraction. What about 2/7? If we plug that in our calculator, we get 0.28571428. Make the number large enough, you'll see there's a repeating pattern right here. So I can actually write this as a decimal, 0.285714. And that bar goes across all 6 of those numbers. So again, this is also non-terminating, but it is repeating. So that's again how we can convert this fraction into a decimal. Lastly, here we have a mixed number. This shouldn't be a big deal, 3.625. So you can see this is terminating. So any number that's terminating, we can convert that fraction into a decimal. If the number is non-terminating, as long as there's a repeat sequence, again, we can write that as a decimal. Let's write some of these fractions as a decimal and as a word. This is important, being able to convert some of these small fractions over to decimals. The words, not so much. I'll start you off here now. 1/10, that's equal to 0.1. And what does that represent? That is 1/10. So try these on your own and we'll take them up. The next one here, 1/100th. We have 0.01, and this is 1/100th. So you can see where this is coming from, where this place value comes from. There is no once. 1/1000, 0.001, and this is 1/1000th with a TH. Here we have 1/10,000, so this is 1/10,000th. 1/100,000, this is 100,000th. And here we just add in those extra zeros. And there you have it. There's a trick here when converting from fractions over to decimals. Let's say we had this value, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had that many zeros. To convert that over to a fraction, what we do, it's pretty simple actually. We just count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, including this first zero. That's equal to 1 over, there's 11 zeros. There's 11 zeros down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see that here as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So one of those little tricks you can do to double check to make sure you converted it properly if that's necessary. This next skill is not as important as it used to be. I don't know how many people write checks anymore. Writing numbers down into word format is not such an important thing anymore. We'll still review it. So what's the process for converting a decimal number into words? So we write the numbers to the left of the decimal as a whole number. We replace the decimal with the word and. Then we write the numbers to the right of the decimal using the place value of the last digit. So let's show you how this works. So here's our decimal. We look at the numbers to the left of the decimal. That is going to be 26. We then replace the decimal with the word and then we write this number here. This number is 498, so we write that whole number down. 498. And then what's the place value of the last digit there? That's tenths, hundreds, thousandths. So this is thousandths. So the number before, the decimal, the number after, and then the last place value. Next one here, there's no number in front. Therefore, we don't need to put in the and. We just write 7. What's the place value? Tens, hundreds, thousands. 7 thousandths. That's how we write that one. Try one more. 840. Notice I said that wrong. I said 840. It should just be 840. Now is the decimal. And that's where the and comes in. 840 and our number here is 67. And what's the place value here? Tenths, hundreds, thousands, 10,000ths, 100,000ths. So that's how you actually say that word appropriately. 840 and 6,700 thousandths. Again, this is not such a big deal anymore. We usually don't need to convert numbers to words, so I'm not going to focus on this too much, but I thought I would bring it up just to make sure you were understood. You can try these practice problems here on your own if you wish. I'm not going to take them up. More importantly, is converting a decimal into a fraction. Earlier, we converted a fraction into a decimal, and that was pretty easy. How'd you do it? You just had to type it in your calculator and hit equals, right? If it's 4/7, you do 4 divided by 7, hit equals sign, and you get the decimal. Maybe I ask you to do this without a calculator. So let's go through the process of how to convert a decimal into a fraction. So step number 1, write the numbers to the left of the decimal as a whole number. For instance, this one here. That's a 2. Write it as a whole number. Count the number of digits in the decimal. How many digits are there? There's 1, 2, 3 digits here. Divide by 1, followed by the same number of zeros as there are digits. So here we have 345. There are 3 digits, 1, 2, 3 zeros. I guess step number 4, simplify. So to simplify here, we can take a 5 out of the top and the bottom. And here we have 2. 1,000 divided by 5 is 200. 345 divided by 5, that's going to be 20, 40, 60, 69. This decimal here is 2 and 69 over 200. I'd like you to try the next 3 on your own. See if you can convert those from decimals into fractions. Let's take it up. So this is 89 and 4. There's 1 digit there, so we put 1 0 in there. We can simplify this down to 2 over 5. So 89 and 2/5. This one here, 674, 54, 2 digits, 2 zeros. We can simplify that down to 27 over 50. Lastly here, there is no whole number. So what do? We write down the digits. 86. We put it over 1. How many decimal places are there? 1, 2, 3 decimal places. So there must be 3 zeros. Can we simplify that down? We can. 43 over 500. So if you follow these rules, it's pretty simple to convert any decimal into a fraction. When comparing decimals, which one is larger compared to another, students can oftentimes be confused when they're doing these problems. Example number 9 shows us where the problems might come about. Here we have decimal 25 and here we have decimal 235. I ask you which one is larger. The problem is that students look at the two numbers and they see 25 here and they see 235 there. And they say, oh sir, this is easy. This one is larger because it's 235. And I will say, I'm sorry, that's incorrect. So when comparing two decimals, number 1, if they have a whole number, check that out first. That's usually the easiest way to go. If there are numbers after the decimal, that's where problems can exist. If they're equal, Compare the decimal parts, starting in the tenths place and moving to the right. Stop until you get two digits that are in the same place, but they're different. Whatever is larger, that's the larger number. So let's look at this now. 0.25, and we're going to compare that to 235. What you want to do, you want to make sure there's the same number of decimal places. So here we have 1, 2, 3 decimal places. Here we only have 1, 2. We can add in an extra decimal here, and we don't change its value by putting in 0. We examine the whole numbers. No whole numbers. Examine the tenths column. Both 2's. Examine the hundredths column. This number's bigger. Therefore, that is the larger number. If you get confused, convert them over to fractions with a common denominator. This one here, 250 over 1,000. This one here, 235 over 1,000. Common denominator, you can clearly see this one here is the larger value. I'd like you to compare these values here on your own. Tell me which one is the larger of the two numbers. Give that a try now. This one here is larger. If I put in the same number of digits in, this one is larger, this one is larger, this one is larger, larger. Be careful of that one. That's a tricky one. You look at those numbers, you're maybe not looking at that first number. So read the whole numbers first before you even look at the decimals, because clearly 43 is a much larger number than 32. Last part of today's lecture. Let's talk about rounding decimals. This should be review for all of you, unless, of course, you were taught differently in other parts of the world. Sometimes rounding is taught differently. So when you're doing calculations or you're measuring numbers in the lab, numbers have to be rounded off. We'll learn very shortly that we can only report the number of decimals based on the equipment we're using. We can't report too many decimals because the equipment is not set to give you that sort of accuracy. So let's review our rounding rules. As an example, let's take the number 3.51750. Let's say we want to round off to 3 significant digits. Step number 1, decide which digit needs to be rounded and underline it. I've been choosing to underline all of them now. I find maybe that's more helpful. It kind of groups everything together. Determine the number that is immediately to the right of the number. So let's look at this. We look at the number beside that, just the one number. Just the one number. If that number is 5 or more, then the number beside it goes up by 1. If it's 4 or less, the number does not change. All the numbers afterwards, delete them. So if we round this off to 3 significant digits, this becomes 3.5. That's a 1. This is a 7. It's bigger than a 5, so that rounds up 3.52. If, however, 3.51750, let's say I wanted to round off to only 2. I look at the number beside that. It's less than 5, so this is approximately equal to 3.5. All the zeros afterwards, all the numbers afterwards, they're just deleted. We don't report them because we've rounded them off. And you might say, sir, I know this. Why are we learning this in this class? This is very elementary. Okay, let's address that. Sometimes, if you have old chemistry professors, they have a different way of rounding. 3.45, 3.35. What they sometimes say is you round to the nearest even number. Let's round both of these numbers using the old school chemistry rounding techniques. So here we look at the number beside that. It's 3.45. Under the rules we just learned, there should be 3.5, right? Because it rounds up. But that's not the case. You round to the nearest even number. So my choices here are 3.4 or 3.6. Those are even numbers, 4 and 6. What's closer to 3.45? This is closer. So this would round off to 3.4. A number like this, it is a 5. We can either round that off to 3.4 or 3.2. 3.4 is closer to 3.35 than 3.2 is. Therefore, this rounds off to 3.4. We will not be using this term. In the end, it doesn't matter how we round. What matters is that we're all doing the same thing. We're communicating, we're speaking the same language. So whatever lab you go to, double check with your professor or your supervisor about the rounding rules. Let's look at some alternative ways of rounding off from different parts of the world. Let's round this off to say 2 significant digits. Under our rules that we're going to work with in this course and in our labs, we look at the number beside it. It is less than 5, so this rounds off to 4.3. However, in other parts of the world, they don't look at the next number. They go back 1, 2, 3, 4 back, and then they start rounding up. So you can see this is a 6, this becomes a 5, this becomes a 5, this becomes a 5. Now this rounds off to 4.4. Confusing, isn't it? That's why communication is important. We will not be using this technique. We're going to look at one number over. We are not rounding to the nearest even number. We're using the old school rounding techniques hopefully you learned in elementary school. But be aware, other systems do exist. For practice, find the place value that's being listed, underline it, and then round it off to that appropriate number. Do that on your own, and I'll write down the answers here. Now, hopefully you didn't have a problem with these. A few things I want to point out. As an example, 1,567.90. Round off to the nearest 10. Look at the number beside that. That's going to be 15. Wrong. Remember, this is in the thousands, hundreds, tens, ones column. I see this all the time. Students round it off and then they forget to add the 0 in. We have to add that 0 in. This is a placeholder to tell us this is in the tens column, the 5 is in the hundreds column, and the 1 is in the thousands column. Don't forget that. Also, this value here. Notice I rounded off to a tenth, 1.02559. I'm rounding it off to the 10th. So I look at the number beside it. I don't just write 1. Why? Because this value is important. It's significant. We're going to talk about this later on. So don't forget, you want to add zeros in as placeholders, and you want to add zeros in if they come after the number, after the decimal, because they will be significant numbers. We're going to talk about those very shortly. So today, we reviewed the decimal system and what place values represent. Then we talked about rounding. This all should be review for you. We want to make sure we're all speaking the same language, communicating properly, and doing the same thing. Until next time.